Continuing on in section 5.1, we're going to write a terminating decimal as a fraction or a mixed number. We use the place of the last digit to determine the denominator of our fraction. So, however many digits are in our denominator, we're going to take that number, take 10 raised to that, and that'll be our denominator. We can also think about it in terms of if we have one digit after our decimal, our denominator is going to be a 1 with a 0, 10. If there's 5 afterwards, 10 to the 5th power will be 1 with 5 zeros, 100,000. So it gives us a little bit of perspective here in what we need. So we figure out how many decimal places we have. Here it's 1. So I take 10 to the 1st power, which is just 10. And that becomes my denominator. In my numerator, I take all of the numbers after my decimal, which here is just 7. So 7 over 10, check to see if that simplifies. 7 is prime, it does not go into 10, so this is our answer. In B, we have a couple extra things here. The negative sign stays negative. Our whole number, 3, stays a whole number. And now as far as the fraction goes, we're only working with our decimal. So I have 2 places after my decimal. 10 to the 2nd power is 100, or 1 with 2 zeros. That is going to become my denominator. My numerator are my digits after the decimal. Here, 0, 5, or just 5. The last thing we want to do is check to see if we can simplify. Well, 5 is prime, but I can divide both by 5. My greatest common factor here is 5, which is going to give me negative 3 stays the same, and 1 over 20. 5 divided by 5 is 1. 100 divided by 5 is 20. And those are equivalent. In example 5, we have a repeating decimal that we want to write as a fraction. And here it gets a little bit different. First thing we're going to do is we're going to write our decimal as an equation equal to x. So I'm going to take 0.93 repeating equals x. Now, I count the number of repeating digits. Here, 1, 2. I have 2 repeating digits. I multiply both sides of the equation by 10 to the 2nd power, which is 100. So I take that 100 and I multiply both sides by it. On the right side, that gives me 100x. On the left side, that gives me 93.93 repeating. We can look at that over here. 0.93 repeating is the same as 0.939393. So if I multiply by 100, I move 2 places and I get 93.93 repeating. Okay, then we subtract our original equation. X equals our decimal. So I'm going to subtract an x equals our decimal. And because those are equivalent, I can do it on both sides. So I'm going to subtract the 0.93 repeating and subtract the x. What that gives me then is 93 equals, remember our coefficient there's a 1, 99x. We can go ahead and divide by 99 to solve for x. That's our final step. And then simplify, reduce if we can. Here I can divide both of these by 3. That's my greatest common factor. And I get 31 over 33 is my decimal. Here's a little shortcut. We can look at this. Say I have 2 numbers after my decimal. So 10 to the 2nd power, 100 minus 1, 99, because we subtracted that x there. Now I can take my digits, the 93 divided by 99, and I get there as well. So we don't necessarily have to write out all these steps if we just use those ideas. Here we're going to write 1.6 as a fraction or mixed number. It's going to be a mixed number because we have a whole number part here. So I keep my whole number. Now my decimal I turn into a fraction. I count up how many places. I have one decimal place. So I take 10 to the first power. I get 10. That becomes my denominator. In my numerator, I just put my digits after my decimal, 6. And then we want to look to see if we can reduce. Between 6 and 10, our greatest common factor is a 2. So I can go ahead and divide by 2, which means my final answer, I keep my whole number. 6 divided by 2 is 3. 10 divided by 2 is 5. So 1 3/5. Now we're going to write negative 9.42 as a fraction mixed number. Again, because we have a whole number part, it's going to end up being a mixed number. We keep our negative. We keep our whole number as a whole number. And it's just the fraction part then, or the decimal part, that we turn into a fraction. We count up how many places we have. 1, 2. So I take 10 to the second power, which gives me 100. And that becomes my denominator. My numerator are my digits after the decimal here, 42. Last thing we always want to do is try and simplify if we can. Here our greatest common factor is a 2. So I'm going to go ahead and divide both by 2. Get negative 9 and 21 over 50. And that is as a fraction or mixed number in lowest terms. Here I have a repeating decimal, and I'm going to write this as a fraction. So again, I'm going to use my shortcut here. I have 2 decimal places, so I'm going to take 10 squared to get 100. But because it's repeating, I'm going to subtract 1 and get 99. And that is going to be my denominator. Now I'm going to take my digits, 72, my numbers after my decimal, and those become my numerator. Last thing we want to try and do here is simplify if we can. I can take a 9 out, it's my greatest common factor, and I get 8 over 11. So again, a little bit different than last time. I didn't work through all of the steps. I used this little shortcut here. So if it's a repeating decimal, we subtract 1 from our denominator and go about it the same way. So that's the only difference. The repeating bar means we subtract 1 from our denominator. On example 6, we need to order these numbers from least to greatest. So we need to have them in comparable forms so that we can look and see which ones go where. Since I have 3 numbers as decimals and 3 as fractions, but 2 of my fractions are the same number parts, 5 over 2, I'm going to go ahead and switch my fractions to decimals. So here, I keep my sign. I take 5 divided by 2. 2 goes into 5 2 times, which gives me 4. I subtract and get a remainder of 1. 2 doesn't go into 1, so I add a decimal. Bring your decimal up. With a 0, we drop down. 2 goes into 10 5 times, which gives me 10. Subtract, and I get 0. So, negative 5 over 2 is negative 2.5. Which also means 5 over 2 is 2.5 from over there. 13 over 3 is negative, so I keep the negative, and then I take 13 divided by 3. 3 goes into 13 4 times, which is 12, remainder 1. 3 doesn't go into 1, so I put a 0, bring up my decimal, and bring that 0 down. 3 goes into 10 3 times, which is 9. Subtract remainder 1, add a 0, bring it down. 10. 3 goes into 10 3 times, which is 9, subtract, we get 1 again. Here it's repeating, so we get negative 4.3 repeating. We can compare now. So we know that negative numbers automatically go to the left. If we were to put these on a number line, from 0, positive numbers go to the right. Negative numbers go to the left. Negative 5 over 2 is negative 2.5. So between negative 2 and negative 3, right in the middle. Negative 0.2 goes between 0 and negative 1, closer to 0. 4.31 is positive, so it goes to the right, and it's more than 4, so we have 4.31. Negative 3. Five over 2 is positive 2.5, so it goes in between 2 and 3, right in the middle, 5 over 2. And negative 13 over 3 we said was negative 4.3 repeating, so it's further away from 0 than negative 4, and we get negative 13 over 3. So here I have my values, least to greatest, which is what we wanted, so I can go ahead and list them out. I have negative 13 over 3, negative 3, negative 5 over 2 because it's negative 2.5, negative 0.2, 5 over 2 because it's positive 2.5, and then 4.31. Least to greatest. And that's all I have for section 5.1.